Hello guys, so for today's video, we will be talking about the summary of Chapter 5 in Cisco CCNA 1. So before we start, again, my name is Mark James Frago, and as you can see guys, we will be talking about the Chapter 5, which entitled the Ethernet. So, uh, the chapter outline. First is the introduction, next one is Ethernet protocol, next one is LAN switches, next one is address resolution protocol, and the summary. So for this section, section 5.1, Ethernet protocol. So we need to explain how the Ethernet sublayers are related to the frame fields and describe the Ethernet MAC address. So let's proceed to the next. So first one is Ethernet encapsulation. So before we tackle about the Ethernet encapsulation, so what is Ethernet? What is Ethernet? So Ethernet is defined by data link layer and physical layer protocols. So Ethernet is the most widely used LAN technology, and it operates in the data link layer and the physical layer. So family of networking technologies that are defined in IEEE 802.2 and 802.3 standards. So it supports with data bandwidths of 10, 100, 1000, 10,000, 40,000, and 100,000 Mbps, or 100 Gbps. So the Ethernet standards is defined layer 2 protocols and layer 1 technologies. So two separate sublayers of the data link layer to operate logical link control, or LLC, and the MAC sublayers. So as you can see guys, this is the Ethernet encapsulation. This is the what they call that, illustration. So MAC sublayer. So what is a MAC sublayer? MAC sublayer, primary responsibilities, data encapsulation, and media access control. So as you can see guys, this is the Ethernet evolution. So first, we have 8 bytes preamble, 6 bytes destination address, 6 bytes source address, 2 bytes type, 46 to 1500 bytes data, and 4 bytes for frame check sequence. So Ethernet 2 frame fields. So minimum of frame size of 64 bytes, collision frame of or rant. And the maximum Ethernet frame size is 1518 bytes, jumbo or baby giant. Ayan. So, topic 5.1.2. So, the Ethernet MAC address. So, MAC address and hexadecimal. Hexadecimal numbering and decimal and binary equivalence of 0 to F hexadecimal. So, as you can see guys, this is the conversion of decimal, binary, and hexadecimal. So, this is the illustration guys. And MAC address, Ethernet identity. So layer 2 Ethernet MAC address is as the 48-bit binary value expressed as 12 hexadecimal digits. So IEEE requires a vendor to follow two simple rules. So the rules is must use the vendor assigned OUI as the first 3 bytes, and all MAC addresses with the same OUI must be assigned a unique value in the last 3 bytes. So this is the illustration of frame processing. So what is the frame processing? The NIC reviews information to see if the destination address in the frame matches as device physical MAC address stored in RAM. If there is no match, the device discards the frame. So if there is a match, then the NIC passes the frame up the OSI layers or OC for the encapsulation process take place. So this is the MAC address representation. Again guys, with dashes 00 dash 60 dash 2F dot 3A dash 07 dash BZ, and with colons, as you can see guys, it is almost the same. This is with dashes, and this is with columns, this is with periods. So unicast MAC address. So unicast, so this is the broadcast MAC address, and this is one is the multicast MAC address. So section 5.2, LAN switches. Upon completion of this section, you should be able, or we should be able, to explain how a switches operates, explain how switch builds its MAC address table and forwards frames, describe switch forwarding methods, describe the types of port settings available for layer 2 switches. So for this topic 5.2.1, MAC address tables, switch fundamentals. So we must learn the basic. An Ethernet switch is a layer 2 device, and it is used MAC for addresses to make forwarding decisions. And the MAC address table is sometimes referred as to as a content addressable memory or CAM table. So learning MAC addresses. So the port and source MAC address added. So this one represents that I don't have the source MAC address and incoming port in my table, so I will add it. For the next one is learning MAC addresses. So the continuation, forward, examine destination MAC address. Filtering frames. So PCD sends frame back to PCA, and switch learning PCDs MAC addresses. So filtering frames, so let's skip that. So let's proceed to this one. Cut through switching. Fast forwarding, forward switching, low level and off latency, immediately forwards a packet after reading the destination address. And typical cut through method of switching, fragment free switching. Switch stores the first 64 bytes of the frame before forwarding, and most networks error and collision occur during the first 64 bytes. Again guys, a cut-through switch forwards the frame before it is entirely received, and at a minimum of the destination address of the frame must be read before the frame can be forwarded. So guys, this one is memory buffering on switches. So first, port-based memory. In port-based memory buffering, frames are stored in queues that are linked to the specific incoming and outgoing ports. And next one is the shared memory. So shared memory buffering deposits all frames into a common memory buffer and which all the ports on the switch share. So guys, the duplex and speed settings. So what is the full duplex? We have two types of duplex. So we have full duplex. So both ends of connection can send and receive simultaneously, and half duplex, only one end of the connection can send at a time. So duplexing speed settings, a common cause of performance issues on 10 over 100 Mbps Ethernet link is when the one port on the link operates at half duplex and the other on full duplex. So this is the representation. So this one states that I'm full duplex, so I can send whenever I want. And this one is I'm half duplex, so I can only send when the link is clear, but I'm also getting a lot of collisions. So I hope guys you can follow my discussion of the summary of chapter 5. So auto MDIX MDIX auto detects the type of connection required and configures interface accordingly. So next one is the section 5.3 address resolution protocol. So we need to compare the rows of the MAC address and the IP address, describe the purpose of ARP, and explain how ARP requests impact network and host performance. So the destination on the same network, there are two primary addresses assigned to a device on Ethernet LAN. So physical address, the MAC address, used for Ethernet NIC to Ethernet NIC communications on the same network. And logical addresses, the IP address used to send the packet from the original source from the final destination. So let's keep that guys. And so for the introduction of to the ARP, I need this is the representation or the topology, and I need to send information to 190.168.1.7, but I only have IP address. I don't know the MAC address of the device that has been IP that has that IP. So what are the functions of ARP? So it is used to find the MAC address that is mapped to the destination of address. So if the destination of our address is on the same network as the source IPv4, the device will search the ARP table for this destination of IPv4 address. So removing entries from an ARP table, ARP catch time removes ARP entries that have not been used for a specified period of time. Commands and also be used to manually remove all the sum of entities in ARP table. So for the chapter summary of chapter 5, that's all for the chapter 5 summary, and thank you. God bless. Again, my name is Mark James Frago from BSIT 2107.